Knoholem project 13 partners from 6 countries with one overarching goal to create a knowledge-based holistic energy management in public buildings. The Knoholem project aims to deliver an intuitive interface for facilities managers to interact with their buildings in a more informed and more effective way than ever before. Based on a state-of-the-art prediction and decision-making engine, the facilities manager is updated in real time about the performance of their buildings and how to improve it. Utilizing artificial intellectual techniques which mimics the way the human brain learns, data from the building continuously trains the decision-making capabilities of the system. This provides a dynamic solution to meeting the requests of the facility manager, such as reducing energy consumption or CO2 emissions.
Building management systems play an important role in the energy management of modern buildings. Now, the main drawback of these systems is, in a sense, they don't capture the complex interplay that takes place between the various systems of a building, the components within systems, and more importantly, the dynamic data and information to do with the environment, occupancy, and so on and so forth. Now, in the Knoholem project, what we're trying to achieve, in a sense, is to develop a smart system that would sit on top of the building management system that would allow us to, that would give us real accounts of the energy profiling of the building, near real-time data about the energy performance of the building, and at the same time provide a capability for the facility manager or the energy manager in the building to optimize the energy performance within the building, taking into account a variety of objectives.
This is the forum building, one of our demonstration objects. In the summer, the main dining area and socializing area often overheats. Sensors around the room record information such as humidity, temperature, and occupancy. These sensors feed into a historical database through which the behavior of the building and the interplay between its systems can be quantified. Before this historical data is utilized, though, the building is modeled in energy simulation software. This is where collaboration is key, as BIM allows the model to be reused from previous modeling. Alongside the simulation model, it is necessary to define scenarios, description of energy-saving use cases specific to each building. These are utilized with the model to perform a sensitivity analysis, a statistical method which determines the key parameters that affect the performance of the building. This allows a streamlined approach to data handling herein, allowing the system to be more responsive to incoming data. Following this, an artificial neural network is developed to approximate the performance of the building given any set of input parameters. This is then trained by using simulated data and calibrated using historical data so that it can provide accurate performance indicators for the building depending on the input parameters specified. The ANN model is then embedded into an optimization loop which utilizes evolutionary algorithms to determine the input parameters required to produce the desired output, such as reduced energy consumption. From this process, a set of dynamic rules is generated which inform the required actions to produce a desired change within the building. The exciting part is that these rules are dynamic. They're being constantly refined based on continual learning of the ANN model from historic data. So if a change is actuated now and its effect is less than expected, the ANN model will incorporate this knowledge into future predictions. The rules generated from the genetic algorithm ANN loop are fed into an ontology, a structured knowledge base containing all the information about the facility, which is really at the heart of the solution.
The Knoholem system involves a number of interesting components which we try to capture through this system architecture. So we have first at the heart of the system, we have the Knoholem ontology, or the Knoholem knowledge base, which in fact is an enhanced version of a BIM, augmented with intelligent rules that make or can provide energy saving capabilities. That's one component. The second component is the real-time data or the mining database. In fact, the metering data we're getting from the building is stored in a mining database. Now, alongside the mining database, we have an interesting component in Knoholem, which is the fuzzy reasoning module. In fact, it's an inference engine which interprets the real-time data that's fed from the buildings through the mining database, and then identifies the rules that should in fact be triggered as a result of the latest state of the building. The interesting thing with the fuzzy reasoner is that it factors in the uncertainty, the level of confidence that we might have in relation to the rules that have been generated. Finally, the last component is the GUI, the user interface, which is used by the facility manager to interact with the Knoholem system. Now, the facility manager has the capability of obviously formulating queries, energy-saving queries, which then are interpreted real-time by the Knoholem system, given the latest condition of the building, and then turned into an optimization plan. The FM has the possibility to revise his plans, his aspirations, energy-saving aspirations, if he or she feels that the targeted energy saving is not achievable. So by an iterative process, we can achieve whatever energy saving is possible given the latest conditions of the building. Returning
now to the overheating dining area. The facility manager can now ask the system for a solution. Enhancing user experience in building is paramount. Hence, it is essential to deal with multi-objective scenarios. For example, maximizing occupants' comfort while reducing energy consumption. This request is sent through the graphical interface to the ontology, which analyzes the rules available to it to determine strategies for achieving these targets.
Based on the decision of the facilities manager, the system implements the selected rules automatically. The building then acts according to the new rules and its sensors record the effects. Now, before occupants get too hot in the dining area, the atrium windows open to encourage ventilation and the shades are activated to prevent solar gains.
Thanks to Knoholem energy characterization approach, we believe that we can save up to 30% energy in public buildings. This is the goal that the Knoholem partners represented on this slide will be pursuing in the next few years.